A master's degree in quantitative finance concerns the application of mathematical methods to the solution of problems in financial economics. There are several light-titled degrees which may further focus on financial engineering, financial risk management, computational finance, or mathematical finance. In general, these degrees aim to prepare students for roles as quants, including analysis, structuring, trading, and investing. In particular, these degrees emphasize derivatives and fixed income, and the hedging and management of the resultant market and credit risk. Formal master's level training in quantitative finance has existed only since 1990. Structure. The program is usually 1 to 1.5 years in duration, and may additionally include a thesis component. Entrance requirements are generally multivariable calculus, linear algebra, differential equations, and some exposure to computer programming. Programs emphasizing financial mathematics may require some background in measure theory. The curriculum builds quantitative skills, and simultaneously develops the underlying finance theory. The quantitative component draws on applied mathematics, computer science and statistical modeling, and emphasizes stochastic calculus, numerical methods and simulation techniques. Some programs also focus on econometrics, time series analysis. The theory component usually includes a formal study of financial economics, addressing asset pricing and financial markets. Some programs may also include general coverage of economics, accounting, corporate finance and portfolio management. The components are then integrated, addressing the modeling, valuation and hedging of equity derivatives, commodity derivatives, foreign exchange derivatives, and fixed income instruments and their related credit and interest rate derivatives. Some programs also cover quantitative portfolio management and optimization. See List of finance topics #financial mathematics. The title of the degree will depend on emphasis. The major differences between programs being the curriculum's distribution between mathematical theory, quantitative techniques and financial applications. The more theoretically oriented degrees are usually termed Masters in Mathematical Finance, or Masters in Financial Mathematics, while those oriented toward practice are termed Masters in Financial Engineering, Masters in Computational Finance, or sometimes, simply, Masters in Finance. Masters in Quantitative Finance is the more general degree title, although MQF degrees are often less theoretical and more practical. The practice-oriented programs are often positioned as professional degrees. Programs are sometimes offered as a Master of Engineering, or as a Master of Operations Research. Comparison with other qualifications. The program differs from that of a Master of Science in Finance, and an MBA in Finance, in that these degrees aim to produce finance generalists as opposed to quants, and therefore focus on corporate finance, accounting, equity valuation and portfolio management. The treatment of any common topics, usually derivatives, financial modeling, and risk management, will be less technical. Entrance requirements are similarly less mathematical. Note that Master of Finance and MSc in Finance degrees, as distinct from the MSF, may be substantially similar to the MQF. There is some overlap with degrees in actuarial science, and both degrees are occasionally offered by the same department. Nevertheless, the programs are almost always separate and distinct. Specifically, whereas actuarial programs cover risk and uncertainty as applied to pensions, insurance and investments, quantitative finance programs are broader, and prepare graduates for various of the highly numerate roles in finance, and for other areas that require quants. There is similarly overlap with a Master of Financial Economics, although the emphasis is very different. That degree focuses on the underlying economics, and on developing and testing theoretical models, and aims to prepare graduates for research-based roles and for doctoral study. The curriculum therefore emphasizes coverage of financial theory, and of econometrics, while the treatment of model implementation, while important, is secondary. Entrance requirements are similarly less mathematical. Some financial economics degrees are substantially quantitative, and are largely akin to the MQF, for students whose interests in finance are commercial rather than academic. A master's in quantitative finance may be seen as an alternative to a PhD in finance. At the same time though, masters in mathematical finance programs are often positioned as providing a basis for doctoral study. History. The first quantitative finance master's programs were offered by Illinois Institute of Technology in 1990, under Drive. Michael Ong. The NYU Poly Financial Engineering degree was the second program of its kind. Carnegie Mellon introduced its Masters of Computational Finance program in 1994. OGI's Computational Finance program was the first such program based in a computer science department. Other pioneering programs include those at NYU's Courant Institute, Columbia, Princeton, UCLA and MIT. Subsequent growth in the number and location of programs has paralleled the growth of financial engineering, with its growing importance across all aspects of the financial services industries, and of risk management as professions. Programs are now widely offered internationally, see links below, and in some cases are available online or via distance education. In a few cases, a quantitative finance MBA specialization is offered. More recently, undergraduate programs are available, both in the US and internationally.